All right, guys, let's talk about discontinuities very briefly. There are several different types of discontinuities. First of all, right here, we have a function that is continuous at x equals 0, and we're going to use this as sort of a model for the next couple. This is called a removable discontinuity right here. We have removed a point. And in fact, both of these are called removable discontinuities, removable. Notice it doesn't matter if there's a value, f of 0. In this case, f of 0 does not exist. And in this case, f of 0 is 2, assuming that, this is 2 and that's 1. Removable discontinuity, easily fixable because all you got to do is stick a point in there. And we'll talk about that in just a minute. If you wanted that to be continuous, you would just redefine the function to have a point right there. This is called a jump discontinuity, and this is not fixable. The only way to fix this one would be to shift a whole part of the function up or down. This is an infinite discontinuity, and again, not fixable because, what do you do? This goes to infinity on either side. There are no limits, and so you can't say, well, we could just make it continuous because the limit does not exist. And this is called an oscillating discontinuity, and we're never going to talk about this again in this class, but be aware that it does exist. So let's talk about removing a discontinuity. How do we get rid of a discontinuity? So let's look at, this is exploration 1 on page 81. And we've got the function f of x equals x cubed minus 7x minus 6 over x squared minus 9. Obviously, the denominator factors, x plus 3x minus 3. This is where dividing polynomials sort of becomes important. I think what I'm going to do is I'll make a new video on dividing polynomials, but this one is a little slightly different division. This is one where we need to do the full thing instead of finding the remainder like we did before. I'll give you another video. I'll throw that up in the next few days for you. But suffice it to say that when I factored this, I got x squared plus 3x plus 2 times x minus 3. I did this by dividing x minus 3 into x cubed minus 7x minus 6. And so a couple things that we notice here. Thing one, this right here is equal to 1. And what it means is that there is a hole in the graph. This is something that you might have learned in pre-calc, but I think you probably didn't get that far. And then just very quickly, I'll mention, and you probably remember this from Algebra 2, this tells us that there's an asymptote on the graph, a vertical asymptote. So at x equals negative 3, there's a vertical asymptote, and at x equals positive 3, there is a hole in the graph. So if we were to graph this very quickly, we've got an asymptote here. We know that this is going to be basically linear because a quadratic divided by a linear is a linear function. Again, going all the way back to algebra. What does the function actually look like? I'm not 100% sure without pulling out my calculator, but let's say that it looks something like that. And there's a hole right here at x equals 3. And I won't worry about the part over here. Okay, so I'm about out of time. I'm going to stop this video and I'll start the next video. We'll pick it up right here.